Hello friends, welcome back to another video on this channel. In today's video, I will show you guys my new creation, a line following food delivery robot system. Basically, the way it works is I have these two line following sensors here, which in reality are just infrared sensors. And the way that works is when it's on the white floor, the infrared sense shoot out by the emitter here, one on one of the sides, and it will get bounced off the floor and go and be received by the receiver on the other end, while on the black color surface, which was in my case a black color tape, like electrical tape basically, then it will no longer be able to see it. So as you can see here, the table can be considered like the black surface and my hand is basically the white floor. So as you can see, when my hand is under it, the infrared lights are receiving and both the sensors are detecting that the white floor is there. Now what happens is when it goes on to the black side, it can see that, okay, let's say for example this sensor went to the black side, so the line would go something like this. So what will happen, it sees, okay, this one has gone to black, this one is still seeing white, which means the line must have gone like this. So it will then turn itself and follow the line like that. So that's the line following part of it. Other than that, I also have two infrared sensors up here. Now these are obstacle detection sensors. So if you see here, when I put my hand close, the idea is the same, but as you can see, it can detect the obstacle. Now you have seen me use ultrasonic distance sensors for the same application before. The way those work is quite simple. This cable just came apart. Anyways, the way those work is a bit differently, but basically that also sends out a sound wave which then bounces back and it can measure the distance, and we are setting that, okay, within this distance it will happen. Now the disadvantage of that is that obviously we are measuring the distance for it, and the way we are measuring it is by actually setting the time. So we're seeing the time between it going and it coming back and it being detected, and then we are dividing that by the speed of sound and then dividing that again by 2 to get the distance. Now which is fine, but in our case what that means is that if we use that, then we'll actually have to stop other loops in the duration of it sending that pulse and coming back. So that basically means either we'll have to lose, like we cannot constantly be checking for these obstacles, which will might mean that it will cause a collision before stopping, or in other case we can have it accurately checked, but that will mean that the other loops, like for example checking the line, won't work. So then it will just not follow it accurately. So for that reason, in this situation we have to use an infrared sensor like this one. So yeah, that's the two sensors. Other than that, in the end you saw it make a U-turn. Now the idea is that from my room it will go to the kitchen, someone will stop it there in the kitchen, put the food inside here. As you see, this is the empty bay for the food. They'll put the food in here, and then it will still continue going, take a U-turn in the kitchen as you saw, and then follow the same path and come to my room, and then it will basically automatically make a 180-degree flip and be ready for the next time I send it. So for that I'm using an HMC QMC 5883L. So this says it's an HMC 5883L, as you can see, but in reality these chips are just QMC 5883Ls marketed as HMC 5883Ls. So the chip you buy and the source you are buying it from determines which one you will get. I'll leave links down below to both the libraries for the QMC as well as HMC. If you face any problems, please let me know in the description. I'll help you guys out. Sorry, in the comments I'll help you guys out. So that's basically it. Now other than that, obviously you saw the smartphone integration part. The way that works is also quite simple. I have this Bluetooth module here. This is the Bluetooth sensor. This sensor is connected to my phone, and on my phone, if I turn it on here, you'll see I have this Bluetooth terminal app. You can just go to Google Play Store and just search up Bluetooth terminal, Bluetooth serial. You'll find many such apps. So just download one, and as you can see, the way it works is I have a command line here. Now I can send the go command to it. It will take it, send it through here, and it will go process the microcontroller will read that through its serial lines. More on the wiring in just a bit, and then after that it will take that data, process it, and know that, okay, now I have got the command to go, so it can then start moving. And for after, another feature I had which I didn't show in the demo video in the starting is that this actually has a stop feature as well, like an e-stop type thing. So I can just type stop and hit the send button, and it will immediately stop the operations there and there. It also obviously has the obstacle detection as shown in the video. The hand which came in the video before putting the apple in was just, it was detecting that is an obstacle. So what it does is once it detects an obstacle, it will stop there forever, and you'll have to then click go again, and it will resume its operation from its point where it was. So yeah, that's basically it for physically, like the idea behind it. Now I'll show you guys quickly the making of it physically, as well as the wiring. So if we look closely here, first of all, wiring for the sensors is quite simple. If I go ahead and zoom in, you'll see that obviously I have it running off of the Arduino Nano here. So just disconnect these lights. Okay, now there, battery off. Okay, then basically I have is this is the Bluetooth module. Now if I take this off, you'll see there are 4 wires, and your label is 4 label there: VCC, GND, TXD and RXD. Now obviously VCC and ground is just power rail, so you'll just send it over to your power rails there. And for TX and RX, this is your serial output. So you'll take the TX of your sensor here, the Bluetooth sensor, and you'll actually send it to the RX of your Arduino. So here you can see RX there. On the Uno as well, if you use the Uno, there also you'll see written RX and TX. So you'll send the RX of the sensor to the TX of the Arduino, and the TX of the sensor to the RX of the Arduino. Basically the flipped name, you'll send it to the other one. That's just wiring the Bluetooth sensor. Other than that, all the 4 sensors, so line sensor 1, line sensor 2, as well as the 2 obstacle detection sensors, they are all single pin sensors. So first of all, 5-volt power goes here in, and then there is just going to be one single digital output which we will be sending to the microcontroller, which goes like this. So your left and right sensors are 2 and 3. Digital pin 2, digital pin 3 is left sensor and right sensor respectively. Then 4 and 5 is the 2 obstacle detection sensors. It doesn't really matter because either way it's doing the same job. It doesn't care whether it's a left one or right one. You can flip it around. And then the rest 4, the other 4, next 4 are just your motor driver pins. So your L298N pins or whatever motor controller you're using. So that's base. And the compass, obviously it uses the standard I2C. So just search up on Google, just search up Arduino, whatever you're using. So in my case, a nano pin out, you'll see SCL SDA written there. So just connect your compasses SCL to your Arduino's SCL port and SDA port to the SDA port. That's the I2C wiring. And then ensure that you are connecting the VCC to 3.3 volts. As you can see, I have it connected to 3.3 volts here, not 5 volts. You do not want to send 5 volts to this compasses. They are all using 3.3 volts only. So now, other than this, I'll show you guys quickly about the powering I am using for this. So as you guys saw, I have one 12-volt battery here. Now this is a custom chassis made. So I am using 2 12-volt motors. If you look in there, you'll see 2 standard geared 12-volt DC motors. They are the motors that I am using. They use 12 volts. So I have this battery here on this platform. The way it is I just have a little one of these like this hook and loop fastener things, and I just stick it onto there, as you can see. And then I have these 2 cables here. Now these are just dangling. It's quite dangerous, especially for a lithium polymer battery, but it's okay, it works. So I'll just have this and I'll just shove them in there. They are a bit frayed, the ends, but that's on purpose so that they friction fit nicely in there. So that's the way it'll connect up to the 12-volt power. Now the way, I'll just disconnect this, and the way it is going in is it's directly coming in here into the L298N's input pins. It's just using a standard internal 5-volt regulator to power the L298N's internal like all the controllers. And then I have the motors coming out of it, obviously, and I also have these 2 wires here. These 2 wires are also connected straight to the 12-volt batteries. As you can see, they're just connected up there, and it goes to this controller here. This is a basically a variable voltage and amperage controller. So I have it feeding the voltage from the battery, and it will give out a fixed voltage whichever you set here. You can adjust it using these 2, as well as it will set a current limit. So I just have it max current. So this is 5. It will do up to 5 amps of current. I don't have the heatsink on it, so it won't do up to 5 amps. I think in my case I measured up to 1.5 ish amps, which is fine for the rest of it, and it will do pretty accurately. It will have a stable voltage roughly for all your sensors. So this is what powers the rail and which powers all the different sensors on board. But the Arduino itself is quite sensitive for even slight voltage up downs will cause it to fail. So for that reason, I actually have a just a standard power bank here. As you can see, it's just standard 5 volt. I have a 5-volt power supply, so I'm just using a standard cable you'll use to connect it to the PC. I'm just having it connected directly onto there, and that's how I'm powering the Arduino itself. So yeah, that's basically it for physically making it. That's basically it. I've told you guys the wiring and everything. Okay, if you guys want to know, I had, as you saw in the video, I had my light here. This light is just a standard bicycle LED light. I just took this bicycle LED light off of its enclosure and I just zip tied this bit here on here, and this is super glued onto here. Another thing, actually, I had a few people messaging me about the compasses not accurately working compasses, and in that case it was my autonomous car video. So that also had GPSs which were not working. Now what you want to do is you want to actually have it elevated up slightly in order to make it work correctly. So that's basically it. I'll go ahead and switch over to the computer and show you guys the code now. Okay, so as you can see now, I have switched over to the computer. This is the code that is running on the Arduino. Now first of all, here is your required libraries. So over here you will these two libraries are already there in the default code. This is the one you'll need to download. Just go ahead and search up QMC583L compass. It will be the first one from GitHub. Just download it and install it. Will be good there. This is your wiring, so you can just see the wiring from here. I also mentioned it briefly in when I was explaining it physically. You can like, this is exactly which pins go where. So after that, for this case, actually, because we have such a complicated mechanism with the Bluetooth inbuilt, the Bluetooth serial part, I'm actually using two bools here. Now this is basically false and true, so 0 or 1. So the way I'm having it is, this is just the setup bit. I've explained this many times before, so just go ahead and see this part here for from either of my previous videos which uses the compass. So you can go ahead and watch the autonomous car video, or you can watch my autonomous firefighting truck video as well. After that, this is the main part. This is the loop part. So first of all, here we are checking for serial. Now we are ensuring that serial is available. After that, we will go ahead and look for the command go. So as I said, when I click go, it will just go ahead and start running. So here we'll set is running bool to true. Now and then we'll serial print going, which is just for our like debugging purposes. Now here, if it is running and is not e-stop, so remember how I mentioned where we can send the command stop and get the robot to stop running. So that's this bit here. So I'll just send it not to stopped, and it is going. Then this if command will start working again, and you can see from here I have this part where I'm first checking all the line sensors as well as the infrared sensors here, and if both the infrared sensors are low, now in this case low means actually detected obstacle, because this infrared sensors are actually the opposite. So when they are normally running, they are putting a high signal or a 1 signal, and when they detect an obstacle, they'll go to low. So for that, once we are detecting that either one of them is becoming low, then we'll set the is running to false, stop the robot, and we'll print in obstacle detected. Now after this, we'll wait for someone to send the go again. So it will just exit here, and it will go ahead and continue checking for this bit. So once it's stopped, okay, it sees that okay, this part is done, it is no longer low, then it will go ahead and start movement again, start continuing down here, and this is the part where it actually sends the line. So as you can see, when either one of them is high, then it will go to the respective side, and when both are high, that means that both of them have not, like both of them are basically on the black line, which means it's the part where it's supposed to stop and then turn 180 degrees. So it'll send this robot to stop. We'll say that line reached. It will wait for a second to ensure that the robot stops completely, and then it will turn 180 degrees. That bit is this this function it will call up. So these are just standard mentions for the motors, and this is the void 180 degree turn function. This one is simple. As I mentioned before, it will take the compass heading, it'll add 180 degrees to it, and it will say that when until it is between 180 degrees, like I'm setting a waypoint of 5, which means that basically within plus minus 5 degrees, as long as it's within plus minus 5 degrees, it will continue to turn, and we are saying that based on which direction it is, so it will either turn left or right, based on which it is a bit closer to at that point. So after that, here we are just going to wait until it turns on. So this while loop will run until it is not within that 5 with like plus minus 5 degrees of the target heading. After it has reached there, we'll wait for 10 milliseconds and we'll stop the robot again, and it will just end this part here, and this will come back up to this part where this part, as you can see, after line is being reached, then we'll set it to false again is running. So after it is set to false, this if command will also then exit this if loop, and it will come up here and wait for this loop again. So we can then go ahead and continue by pressing go, and it will complete the whole loop again. So yeah, that's basically it for today's video. I hope you guys enjoyed this. If you did, please be sure to leave a like, subscribe, and I'll see you guys next time.